All right, we're going to start going over the last two problems of the 2018 January geometry exam. All right, so let's work on number 34. All right, it says, as shown in the diagram below, an island is due north of a marina. A boathouse H is 4.5 miles due west of the marina. From the boathouse, the island is located at an angle of 54 degrees from the marina. Determine and state to the nearest tenth of a mile the distance from the boathouse to the island. All right, so the good thing is here that they have a diagram for you. Now, if you see all the due north and the due west, and those things really don't matter in this problem. I mean, it would be nice if you understood what those meant, but we have a diagram here. The island is I, the marina is M, and the boathouse is H. So they tell you what the variables mean, or what the vertice letters are standing for. So pretty much, this is pretty straightforward. All right, we have a right triangle. Whenever you have a right triangle, you're either going to be using Pythagorean's theorem, a squared plus b squared equals c squared, or you're going to be using SOHCAHTOA trigonometry, sine, cosine, tangent. I tell my students, anytime you see an acute angle given to you, or if you're looking for one of the acute angles of a right triangle, it's always going to be trigonometry. In this case, we have an acute angle of this right triangle. We're looking for a side. We're going to have to use our SOHCAHTOA, which is sine, cosine, and tangent. SOHCAHTOA. All right, SOHCAHTOA. So, let's look at it. Let's determine and state to the nearest tenth of a mile the distance from the boathouse to the island. So the boathouse is H, and the island is I. So they want us to find this side that I'm marking in red. Now, you always want to label your triangle based on the acute angle. So what I mean by that is you have three sides of a right triangle. You have the opposite side, the hypotenuse, and the adjacent side. So based on this angle, over here is going to be the opposite, which would be IM. The hypotenuse is always going to be across from the right angle. So that's going to be our hypotenuse. And then the other side is our adjacent side. All right, so in this problem, we're looking for the hypotenuse. We have the adjacent. We're not looking for the opposite. We don't have it as a piece of information. And since we're not looking for it and we don't have it as a piece of information, it's not going to be used. So which one of our trig functions uses adjacent and hypotenuse? Well, that would be your cup, part of SOHCAHTOA. That's going to be cosine. The cosine of the angle is equal to the adjacent over the hypotenuse. All right, so let's go ahead here and write cosine. Our angle is going to be 54, is equal to the adjacent, which we know, which is 4.5, over hypotenuse, which we could call x. You can call it whatever you want, but we'll call it x. Now, in this case, what I have my students do is always take this cosine of 54, or whatever the angle is, whatever the trig function with the angle, and I have them put it in the calculator and make it into a decimal rounded to 4 places. So, let me clear this out here. So, again, let's make sure you're in the right mode. I'm in degree mode, which I want to be. If you're taking this test and you're using one of these calculators that they give to you, it's going to be in radian mode, most likely. You're going to have to change the mode to degrees. All right? I'm going to come out here. I'm going to do cosine of 54. All right, so I'm going to round that to 4 decimal places. All right, so here, I'm going to put this here. All right, 4 decimal places would be 0.5878. I have to put the 0 over here. Equals 4.5 over x. Now I just put this over 1. Now we can cross multiply pretty easily here. So we're going to just cross this and cross this. So we end up with 0.5878x is equal to 4.5. Then we divide by 0.5878. Divide by 0.5878. And we end up with x is equal to approximately 7.7 miles, 7.7 miles. Be careful on the rounding. Whenever they have this to the nearest tenth, if you had rounded that to 7.8, yeah, let me just put this in the calculator to see what it is. So 4.5 divided by 0.5878. All right, so, okay, let's just say that should go to 7.7 because, let's just look here. Okay, the reason is because we have the 6 and the 5. The 6 is in the 10th place. The 5 tells that to go to 7. If you had written 7.6, you lose a point. And it's a shame to do all that work and then lose a point because you don't round correctly. This is a 4-point problem, so 1 point is losing a lot. All right? Okay, let's do the next part. Now it says determine and state to the nearest tenth of a mile the distance from the island to the marina. Okay, so that's just going to be this what I'm about to outline in blue. All right, so now, based on our angle, again, we have our opposite, and so in this case, I'm going to move this little x here, because in this case, we actually are looking for our opposite. We have the adjacent, so the hypotenuse is not going to figure in. That means in this case, we're going to be using opposite adjacent. That's going to be tangent. So we're going to come down here and say tangent of 54 is equal to the opposite, which is what we're looking for. We can call that y. I'll call it y because I don't want to call it x since I already called the other one x, so I'll call that y. I'm going to say y over 4.5. They won't mark it wrong if you call it x. I'm pretty sure, but just to be sure. All right, now I'm going to put in tangent of 54. So tangent of 54, and I'm going to round that 1.3764. So 1.3764. 1.3764 is equal to y over 4.5. Now I'm going to put this over 1, and I'm going to cross multiply. We don't have to divide in this case because it's going to be y times 1 equals. Then once you put that in, you end up getting 6.2 miles. There you go. So that's it for that one. And we're going to move on to the last one. All right, now we have our last problem of the exam. It is a 6-point problem, so there's a lot to it. All right? Okay, so let's get right to it. It says, in the coordinate plane, the vertices of triangle PAT are, then we have our points here. It says, prove that triangle PAT is an isosceles triangle. The use of the set of axes on the next page is optional. We actually are going to use those. You don't have to. That's why it says it's optional. Now, what I want to talk about here is it's asking you to prove that triangle PAT is isosceles. Okay? It's not asking you whether it is isosceles because they could ask you a question like that. They could ask you to show whether or not it is. And in that case, you say whether it is or not. Here they're saying prove that it is. So it's not a question of whether it is. It's a question of you doing enough work to prove that it is. Okay, so don't go into this thinking, well, is it or not? That's not the question. The question is, can I give enough information to prove that it is? Okay, and there is a way to do it. We just have to figure out what it is. All right, so looking here. If you can show that the triangle has two sides with equal side lengths, okay, that's kind of bad English here, two sides with equal lengths, then it is an isosceles triangle, all right? If you can show that the triangle has two sides with equal lengths, then it is an isosceles triangle. That's the method we're going to use here. All right, we're going to, now, so go ahead and copy this down. I'm going to go over to the graph. And we are going to graph these, and then we're going to find the lengths of all three sides. All right, so let's come over here, and I'm going to erase some of this stuff here. And I'm going to erase this, I'm going to erase this, and that. All right, so now we have this triangle here, so make sure and graph this triangle. So pause it, graph it, or I'm going to get right to it. All right, so I'm going to find the lengths of all thrh sides. So Now, okay, if I'm looking at this, I'm probably thinking that my two sides that are going to be the same are going to be AP and AT, okay? But I'm going to find the lengths of all three sides because that's going to help us in the rest of the problem. All right, so if I want to find the length of AP, what I'm going to do is make a right triangle from A to P, all right? This can be used for your slope and also to find the length of the side. All right, you can also use the distance formula, but I'm not going to use that here. All right, so let's see, AP. So AP, all right. In order to do that, okay, so now we're going to count. Whenever you use this method, the side you're looking for the length becomes the hypotenuse of your right triangle. So AP, right here, is the hypotenuse of your right triangle, right? So if I count here, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this is going to be 3. So that's going to be 3 squared plus 11 squared is equal to C squared. C is our AP, right, the length of AP. So we're going to have 9 plus 121 is equal to C squared. 130 is equal to C squared, and then take the square root. C is equal to radical 130, square root of 130. So I'm just going to put that right here. No need to make it into a decimal because we're just comparing it. All right, so the length here, the length is equal to radical 130. All right, also what I'm going to do is also find the slope. Just because I know what I'm going to have to do in the rest of the problem, that's going to help us. And I always tell my students, find the slope also because once you have the length, or once you do the work for the length, the slope is right there. And vice versa. Once you do the slope, the length is very easy. So since I'm going down from left to right, from A to P, it's actually going to be a negative. Remember, slope is rise over run, so it's going to be negative 11 over 3. Okay, so that's the slope of AP. All right, now, what about let me see, PT. Let's do PT. No, I'll do AT now. All right, so let's do AT. All right, so the length, and the slope. All right, so AT is going to be, same thing, I'm going to count, make a right triangle from here, right here. You don't have to do the dotted line. I don't know why I like to do that, but I'm doing it. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. And this here is going to be 1, 2, 3, 4, 5, 6, 7. So what we're going to have here is 7 squared plus 9 squared is equal to C squared. C is going to be our AT. That's going to be 49 plus 81 is equal to C squared. 130 is equal to C squared. And C is equal to radical 130. All right, so my length is radical 130. Also, my slope is, remember, it's rise over run. So our rise is actually negative. It's going down from left to right, so it's going to be negative 7 over 9. All right, negative 7 over 9 is going to be my slope. All right. Now, let's find the length of the other side here. The length of the other side is, so that's going to be PT. All right, so we've done enough to prove it's an isosceles triangle because of the fact the lengths are the same. But let's just find PT, and that's going to make it, that's going to maybe help us in the next part. All right, so we have the length and the slope. So from here, we're going to count over and up. So our rise is going to be 1, 2, 3, 4, and our run is going to be 1, 2, 3, 4, 5, 6, 6. Yeah, 6. Okay, so our slope is actually going to be 4 over 6, and reduced, that would actually be 2 over 3. So, or 2 over 3. I always tell, you're going to end up using the slope to compare it to other slopes, so you want to reduce it. All right. So for the length, you're going to do 4 squared plus 6 squared is equal to C squared. And then you're going to have 16 plus 36 is equal to C squared. And then you're going to have 52 is equal to C squared. And take the square root. C is equal to the square root of 52. All right, so square root of 52. All right, so now let's go back. Let's write down something. All right, don't have to write much here. basically you could just say, all right, PA is equal to, or what did we say? We said AP. Okay, I think we said AP. That really wouldn't matter, but AP is equal to radical 130. And then AT is equal to radical 130. And PT is equal to radical 52. All right, so since two sides, since AP is equal to AT, triangle
Students, that was the warning bell. Please make your way to your second period classes at this time. You should not have any students in the hallway after the bell rings. You have more than enough time to get to your second period class.
So that's the first part. Now, we have to jump to the next part. All right, the next part says state the coordinates of R. So the quadrilateral PART is a parallelogram. All right, now, so that means we have to go back here, and we have to put a point somewhere that would make this a parallelogram. Okay, so I'm gonna erase some of these things now, and where could we put R? Where could we put R so that it's a parallelogram? All right, so if you think about it, R should be somewhere up here, right? But we have to figure out exactly where it should be. Okay, now remember, parallelogram opposite sides are congruent. Opposite sides are also parallel. So if I'm looking, wherever I put R up here, the length of AR, so let's just say R is here, right? The length of AR has to be the same as the length of PT. And also the slopes have to be the same. So we can take that, use that information in order to find where R should be. So if I go from P to T, well, we already know what the slope is. The slope from P to T is 4/6. So if we go from A up 4/6, that should be where our R is. So it should be pretty simple here. So I'm going to count 1, 2, 3, 4, 1, 2, 3, 4, 5, and 6. So that should be where my R is. All right, so if I make my side now from here and then here, right? There we go. There we go. All right, so yeah, that looks right. All right. Now, what are the coordinates of that point? Well, it looks like it's going to be 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 9. So you really don't need to show any work here. So the coordinates of R would just be 2, 9. All right. So that would give you a point there. Probably, I would say 2 or 3 points for this, maybe. And all right. So now.
Close your doors. We're conducting a second period hall sweep. All students, if you have not made it to class on time, knowing that you didn't have enough time to get to class, please make your way down to the cafeteria at this time. Thank you.
Okay, so now it's asking to prove that quadrilateral PART is a parallelogram. All right, what do we have to do to prove it's a parallelogram? All right, well, if we can prove that two pairs of opposite sides are congruent and parallel, that would be enough. All right, so let's go ahead. What I'm going to do for all the sides of this quadrilateral is find the slope and the length. We'll go from there. All right, so let's look at one part of it is AP. So we already found AP and we have PT. We actually already have two sides of it right here, AP and PT, right? So let's just write that up here. So AP, all right, length is equal to that, and the slope is equal to -11/3. Okay, then the other side we have is PT. We have length is radical 52, and then the slope is equal to 4 over 6 or 2 over 3. All right, now we have to find the other ones. And what about AR? Yeah, so let's do AR. All right, AR. All right, so A to R, again, we already kind of did the work for the slope when we tried to figure out where R is. But let's just go ahead and remember the slope is up 1, 2, 3, 4 over 1, 2, 3, 4, 5, and 6. So our slope is 4 over 6. So our slope is 4 over 6 or 2 over 3. And our length, well, for the length, you just do 4 squared plus 6 squared. So right here, we're just going to do 4 squared plus 6 squared is equal to c squared. And all of that gives you 52 is equal to c squared. Take the square root, and c is equal to the square root of 52. C is our AR, so it's the square root of 52. And our last side is going to be RT. So let's find RT here. All right, the length and the slope. Okay. All right, so from R to T, you have to go down and over, or over and down. Either way, you have to go down, right? Nope, I didn't go over enough. All right, that's actually here and then here. So that's negative 11. This is 3. So it's actually negative 11 over 3. All right, so negative 11 over 3. And then our distance is going to be 3 squared plus 11 squared is equal to c squared. We already know that that's equal to 130 equals c squared. C is equal to radical 130. All right. So we have now all 4 sides. We have the slope and we have the length. So we can now write up our proof. All right. We can now write up our proof here. All right, so I'm going to have to erase some of this stuff now. You're going to have to find room somewhere. All right, so what do we need to say to prove it's a parallelogram? There are a number of things we could do, but I would say we have AP. Let's just look at AP and RT, right? AP and RT. So they have the same slope. AP and RT. That means they're parallel. So we can say that AP is parallel to RT because they have the same slope. And we could say that AR is parallel to PT. AR is parallel to PT because they have the same slope. And since you have 2 pairs of opposite sides that are parallel, that's enough to prove it's a parallelogram. Okay, since there are 2 pairs of opposite sides that are parallel, quadrilateral, PART is a parallelogram. All right, that's it. A lot of work, but that's a 6-point problem. All right, so we're done with going over the test. Hopefully it helped out. If you're in my class and you have any questions, you can come ask. Otherwise, hopefully you do well on whatever test you're taking.